So I got cut off in the other video. This is video 2 of Unit Exam 2 review. I'm going to do the finding the reasonable domain and range for this problem over here. Number 9, the car problem, and it's the last page in the front. So a car can travel 32 miles for each gallon of gasoline. The function, so they give me the function, d of x equals 32x. And then they tell me that d of x is the distance and that x is the gallons of gasoline. The car's fuel tank holds 17 gallons. So remember here I'm doing domain and range. So I'm going to write over here domain. I know that that's my x, and in this case it will be gallons. And I need to find a start and a stop for domain. I'm going to do the same thing for range. Range, in this case, which is y, is my d of x, which means distance in miles. So the miles. I forgot to underline miles here. Distance in miles. Okay, so I'm also going to put start and stop. What are my limits here? Okay, so I've already decided when I wrote this that this is a continuous function. When you're driving a car, you can use fractional amounts of gasoline. As you are driving, you are using fractional amounts of gas as the car goes. And you can also travel fractional amount of miles. All of that is included. So it is a continuous function. Okay? Over here they tell me that the tank holds only 17 gallons. Remember, my domain is in gallons, so they already gave me the border here, or the star stop for the domain. If it only has 17 gallons, that means that that's it. That's the border, 17 for domain. And obviously when you start it, 0 miles, or 0 gallons, I'm sorry. So you can go from 0 gallons to 17 gallons in this space of time for this situation. And x would be in between that. You can use from 0 to 17 gallons of gasoline in this situation. So I have my borders or my start stop for domain. Now for range, I know I can start at 0 miles, but I don't know when I will stop. It doesn't tell me in the problem. However, I do know that I can only use 17 gallons because that's it. That's the limit the car holds. And I do have the equation, 32 times x. So if I know the x is 17, I could definitely calculate for the distance. So what is d of x when x, or the gallons, are 17? So you would multiply, and d of x would be 544. Okay? So you use the equation they give you there, the function, so that you can calculate how many miles you would travel once you used up all of the gas in the car. And that is the 544. So that means that my stop would be over here. I can go from 0 to 544 miles. Miles, or y. So now I just need my inequalities, right? So this one, because it's a real life situation, it's easy to know. X and 17. I cannot use more than 17. I have to use less than that because that's all the car fits. So x would be less than the 17. And I can use exactly 17 gallons, so, or equal to, would be there. Remember, when we're doing this, they both face the same direction, but you can try it out. For 0 gallons, you have to use greater than or more than 0 gallons, and you can also use exactly 0 gallons when you first start. For the miles, you cannot go over 544 because you already ran out of gas. So from 544, it has to be less than that amount of miles that you travel. And it can be exactly 544 as well. From 0, you know that it has to be greater than 0 or exactly 0 miles traveled. And that would be my domain and range. The next one is just like the Gulliver's or Travels, where they ask you for f of 1. So The inside is the input or the x. So when x is -1, what's y? Here is x -1. And when x is -1, y is 3. So your answer would be 3. In this last one, and this is the last one I will go over, they're asking you to find h of a, which is the function that, or it says that height is a function of the years old, and this should be months old. Sorry about the typo, since this is in months. So height is a function of age, and so age would be the input because it's inside, so the x, and height would be the output or the y. And they want you to find the function. So this is where you would do that 3-column table, and here we have enough space where I can make like the third column be there, where you have the mx plus b here. Okay, so I would find the difference in the y's over the difference in the x's. So plus 4 would be the difference in the y's, and plus 6 would be the difference in the x's. So that my slope would be 4 over 6. And that simplifies to 2/3. So 2/3 is my slope. So I will put it over here and over here and over here. 2/3. Now I have to input my x values. So times 6. This right here, I'm going to expand it in big over here so you can see it. This is too crunched up. Okay? Here you can multiply across, like 2 times 6 is 12, and then 3 times 1 is 3, and then divide. Or you can simplify diagonally here by 3. You get the same answer of 4. So we know that 2/3 times 6 is 4. And then how do I get from 4 to 26? Well, I have to add 22. And then I do the same just to test it out, since I already found my b. My b is 22. And I will try it out with the next one. Okay, 2/3 times 12 would be 8. And 8 plus 22 does give me 30. So now I know that h of a would be 2/3 a plus 22. Okay? If you want to figure out what h of 36 is, instead of a, you will put 36. So you will evaluate the function that you just got. And instead of a, you want 36. Okay, again, you can multiply across, or here you can simplify this. 12 times 2 is 24, and 24 plus 22 would be 46. So 46 would be the answer. Okay? In this one, I'll let you think more about it and finish it yourself. But if h of a is 324, so here's my function. So if the output is 324, so all of this h of a is 324. So instead of h of a, I'm going to write 324 equals 2/3 a plus 22. So now I'm looking for a. And then we'll see if we can figure it out. All right? Peace. Everybody did really well in class. Those of you that didn't come to my class, I am sorry. You have all your notes here. So I'll briefly go over. But remember that in order to tell if it's a function or not, we are going to see if each input has one output. For example, in this one, the input of 3 has an output of 1 and of -1. So if I were to draw a map, that 3 would go to 1 and to -1. It cannot have two outputs, so this would be not a function. In this case, each of these has its own arrow. I mean, I know they're all going, if you were to draw a mapping, all go to -4. but each input has its own arrow, its own output to that. So this is a function. Whenever you have graphs, you can do the vertical line test to see that the outputs don't repeat. I'm sorry, the inputs don't repeat, that each input has only one. For example, here, that input of 2, okay, x equals 2 has two outputs, this one and that one. It touched twice, so not a function. In this case, that input only has that one output, so this would be a function. Okay? When you tell whether it's linear or not, so right now we were deciding if they were functions or not functions. This one, if they are linear or not linear, that's when you do the ratios of the difference in the y's over the difference in the x's, like we did for the slope. So here, for example, would be minus 4, minus 4, plus 5, plus 5, plus 5. The three ratios of these points, negative 4 over 5 equals negative 4 over 5, and it equals negative 4 over 5. All the ratios are equal. Remember, sometimes like you can't say, oh, all the numbers are equal, so they're linear. If they're not equal over here, they're not linear. No, remember, you have to put them in ratios, and when they simplify out, they have to be the same for it to be linear. In this case, it worked out that way, and they were all the same, so they are linear. In this case, you have over here plus 2, plus 6, and plus 10. This doesn't necessarily mean that they are not linear, okay? But when we go over here, we notice that these are consistent, plus 2, plus 2, plus 2. So we already know that the ratios will be different. You will have 2 over 2, 6 over 2, and 10 over 2. And we already know that 1 is not equal to 3, and 3 is not equal to 5. So the ratios are not the same, so this is not linear, and this would be linear. All right, with that I conclude the review. I'm sorry I jumped around. I just kept remembering that half of you did not come to my class today, and I wanted to give you a little bit more of a review. This is due tomorrow, as well as the 2 exit tickets that look like this, and the other one that looks like this. So please bring it for credit so that you can have some extra points on your test. Thank you for watching.